Hi there, and thanks for taking a look at this second video on angles. At the beginning, I will mention all the laws that we looked at in the first video so you can check your understanding of those. In this one, we are going to look at all the angle laws associated with parallel lines. And at the end, I'll go through a couple of questions where we combine all the laws that we've looked at so far. I hope it's useful. So as this is the second of my angles videos, I just want to quickly mention the topics that we covered in the first one, so that if you feel you're not fully confident with them, you can go back and take a look at that video first. I'll add a link in the description. We looked at the names of the different sizes of angles, acute, obtuse, etc. As well as that, we considered the rule of angles inside a triangle, inside a quadrilateral. We looked at angles on a straight line and angles around a point. These are still going to be valuable to us in this video when we're answering questions at the end, so please do take a look at the other video if you need to do so. So now we're going to move on to another set of laws linked to angles, and I'm going to use this diagram. You see it quite commonly in textbooks. It is a straight line which is crossing a set of parallel lines. What we have here are two junctions where the straight line crosses each of the parallel lines. If you look closely at this point and this point, you can probably see that the angles in each of the junctions are the same. And this is why this diagram makes such a good tool to allow us to learn the angle laws. Let's start then by putting a number to one of the angles. And let's say, for instance, that this angle here is 60 degrees. The first angle law tells us that vertically opposite angles are equal. This means where we are looking at two cross lines here, if the angle that we've already highlighted is 60 degrees, the angle on the other side is also 60 degrees. Now, the important thing here is to know that law, because when you are answering a question on angles, you can simply say, if this angle is 60, then so is this, because, and a question will quite often ask you to quote the rule to justify your answer. So you would write, this angle is 60 degrees because vertically opposite angles are equal. At this point, we can make use of some of the angle laws that we learned in my first video to complete the junction at the top here. For instance, if we know that this angle is 60 degrees, then this angle here must be 120 because they are angles on a straight line. Therefore, they have to add up to 180. Now, to find this angle, we have three ways of doing it. It is on a straight line with this bottom 60 here. It is also on a straight line diagonally with the top angle here. It is also opposite to the 120 degree angle. So using any of those rules, we can say that this angle has to be 120 degrees. If you want to check those figures, you add all four angles up, and we have angles around a point which add up to 360. Now, going back to the fact that we said that the two junctions here are identical, this means, again, if this angle is 60 degrees, then this angle here must also be 60 degrees, because the angle at the bottom here at this junction is the corresponding angle to the one at the top junction, and indeed the title is corresponding angles. So the law that we are able to quote for this situation is that corresponding angles are equal. Now, it's important to note here that in fact those two angles highlighted are not the only two, because if you look at the diagram, we can see that this angle here corresponds to the same angle on the lower junction. Also, the one here is corresponding to this one, and finally we have this angle which corresponds to that one. So given the size of any of these angles in the top junction, we can use this rule to find the size of the corresponding angle down at the bottom here. To demonstrate our next rule, I'm going to start with the 60-degree angle again, and I'm going to use two different rules to find two more angles. So once again, I am going to complete this angle here because it is the corresponding angle with the top one. At the same time, we've already done this once, but we are going to highlight that this angle is 120 degrees because it is on a straight line with the 60. Now let's remove the 60-degree angle because I want to look at the two that are left. These two are also part of a rule. They are within this shape here. Sometimes it's called a C shape, and if we look at the two angles, they add up once again to 180 degrees. This gives us another rule. These angles are called co-interior angles, and there is your rule. Co-interior angles add up to 180 degrees. What is a little bit confusing about this is that they actually do have another name, and they are sometimes known as allied angles. They are exactly the same thing, 180 degrees in total. We are now looking at two angles for which we've already found the size. We know that this one was 60 degrees, it was opposite the original 60 degrees, and we know this is 60 because it was the corresponding angle to the original 60-degree angle. These, however, have their own relationship because in fact these two angles are always the same. That gives us alternate angles. That's the name for these two and the relationship between them. Alternate angles are equal. In this case, we have two sets of alternate angles because this one and this one are also equal. We know already they are 120 degrees because of the rule of angles on a straight line. You can see through this that we've used one rule to find another. And this is important because this is what we need to be able to do when looking at an exam question. Sometimes these rules are hidden within diagrams, so I want to have a look at a couple before we end. So here is a very typical question you might find on an exam paper. And the first thing I want to draw your attention to are the words at the top because these are quite common. It says diagram not accurately drawn. What that's warning you is not to stare too much and try to use your eyes to work out the angles. They will not be accurate to what they are saying. This is probably not 155 degrees on the diagram, and the two parallel lines may not even appear to be parallel. So what we need to do is rely on the numbers and the symbols. This picture has got a set of parallel lines, we can tell from the chevrons here. It then has two lines crossing the parallel lines in different directions. First thing to note is the two lines that are crossing, this line here and this line here, are not related in any way. We've been asked to find x and we've been asked to find y. What we have to do is give the size of the angle, but also the reason or the law that gives us the answer. X is the more straightforward one. Now, a good idea with a question like that is possibly move your head around, move the paper around so you can see the picture. If you look at the angle which is 155 degrees and look at the angle X, you can see that they are the same angle on two identical junctions here. In other words, they are corresponding angles. Therefore, it is sufficient to say X equals 155 degrees, and then you write the rule because corresponding angles are equal. That gives you the full marks. Y is possibly not quite so straightforward. It doesn't have a direct relationship with anything else, but we need here to be looking at this junction and this junction. Now you can do this in a couple of different ways. We have the 98 here. If you're not sure what to do, you could simply find all the other angles around this point. For instance, this is 98 degrees. If you were going to use this, you would say opposite angles are equal, therefore this is 98 degrees. You could, however, also use angles on a straight line. So we know they add up to 180, therefore if this angle is 98, then 180 minus 98 gives us 82 degrees. If you want to complete the whole set, opposite angles are equal. This is therefore 82 degrees. Having found these three angles, and you didn't need to, you could have found any one of them, we can then use an option as to how to find y. For instance, this angle at 82 and y here, again look at the diagram closely, are alternate angles. Therefore, you can say that y is 82 because alternate angles are equal. Alternatively, you could use this 82 and look at its relationship with y because these two are corresponding angles. Also gives us 82 as an answer. And finally, if we look at the 98 and y, we can see that these are allied or co-internal angles, therefore they have to add up to 180. So again, 180 minus 98, 82 degrees. So by finding any of the other angles on the bottom point here, we can then use an appropriate rule to find the relationship with y. And in any case, you would say y equals 82 degrees because, and quote the angle of your choice. I'm going to finish this video by looking at a diagram which combines some of the rules we've seen in this video and also in my first one. Again, important, diagram not accurately drawn. This will become very apparent in this example. So we have, once again, a set of parallel lines. And just to make sure we know that, here are the chevrons. Now this time the two lines do not cross the parallel lines, they move between the two, but we can still use the angle laws that we've been using so far. We need to find x. What we know is that this top angle is 70. We need to work our way, and this is quite common that you work your way through a diagram to get to the angle that you want. The first thing that you might want to do here is use the law of alternate angles, because that means that if the top one is 70, this angle here is also 70. So you would quote that. It is 70 because alternate angles are equal. Now, this is where the inaccurate diagram would let us down if we tried to use our eyes, because it looks like a very random triangle. But we have two little marks here which tell us that these two sides are the same. So although in appearance it doesn't look like it, it is in fact an isosceles triangle. We can therefore use that to our advantage, because if it's isosceles, it means that the angles at the base of the isosceles are equal. Therefore, this angle here is also 70 degrees. This is the third angle in the triangle. Now we know that angles inside a triangle add up to 180. Therefore, these two first ones add up to 140. So that must mean 180 minus 140. This angle here has to be 40 degrees. Now we come back to another of our angle laws, and that is angles on a straight line. We have a straight line here. This angle we have already decided is 40. Therefore, to add up to 180, x must equal 140 degrees. Some of these exam questions can look a little daunting. I think good advice is to take them one step at a time. If you're not sure exactly what direction you need to go in to solve a question, think of the angle laws and see if you can apply them to any of the angles on the diagram, and that may reveal your route. I hope you found that useful. We do also need to look at angles inside polygons, and I'll be covering that in a third angle video. In the meantime, please do subscribe to my channel. I do try to bring out videos regularly, and hopefully I will see you again. Thank you.